Hello AFDA students. Today we are going to solve problems using linear programming, and we are going to start by reviewing inequalities. So remember, an inequality looks a lot like an equation, but instead of an equal sign you might have a less than or a greater than, less than or equal to, or greater than or equal to. So we're going to start by graphing y is less than 3x, and I'm going to ask you to open a new tab in Desmos and graph y is less than 3x in Desmos. You can pause the video while you do that. Okay, so in Desmos you get a graph like this. So the line y equals 3x starts at 0, it has a y-intercept of 0, and it has a slope of 3 over 1. 3 over 1. You have a dashed line anytime your inequality doesn't have an equal sign on it, because that means that we're not actually including the line, we're just including all of the points, in this case, that are below the line. So we're going to graph this on your paper now. So you want to graph the y-intercept at 0 and do a slope that's up 3 and over 1. And then you want to remember to make a dashed line that goes through these points. And remember, your line goes on forever. And since y is less than 3x, we are going to shade below the line. These are all the values where y is less than 3x. So what does the shaded area represent? It does have a name. It's called the feasible region, and we're going to get to that soon. But the shaded area represents all of the points that are solutions. So there are an infinite number of points in this shaded area, and all of the points that are in here would be solutions to your inequality. So all of the points that are solutions. So if you are watching this video in class, right now you want to look around in your group and identify somebody to be expert A, expert B, and expert C. If you don't have 3 people in your group, then you can start with A and B, and whoever finishes first could be C. If you have more than 3 people in your group, then 2 people could be expert A or 2 people could be expert B. So you can figure that out. Alright, so if you are becoming an expert, try this on your own. If you're watching this later, then you can continue watching. It says, create a point that is in the shaded region and display its coordinates. So I'm going to use a new color to create this point, and you can choose any point in the shaded area, but I decided to choose the point 2, 1. So I colored it right there, and I'm going to write the point 2, 1. Now remember, the first part is your x and the second part is your y. So I'm going to substitute into y is less than 3x. So for the y, I'm going to put 1 is less than 3 times x, which is 2. I get 1 is less than 6. And this is true. 1 is less than 6. So that means that the point 2, 1 is a solution for my inequality because it makes my inequality true. So when it says you want to see if the point is a solution, we can say yes, 2, 1 is a solution. And then it says circle the conclusion. Points in the shaded region are or are not solutions to the inequality. Well, this point in the shaded region was a solution, so I'm going to circle are. Points in the shaded region are solutions to the inequality. Alright, so now expert B would create a point that is located on the line and record its coordinates. So I can pick any point on the line. I'm going to pick this one right here, which is 1, 3. And I'm going to substitute into y is less than 3x, so I have 3 is less than 3 times 1. So I get 3 is less than 3, and 3 is not less than 3. 3 is equal to 3. 3 is not less than 3. So this is not a solution. So I'm going to say no. 1 comma 3 is not a solution. And down here, points on the dashed line are not solutions to the inequality. Alright, next one. We're going to pick a point that's in the unshaded region and record its coordinates. So I chose the point 0, 5. Let's look at the point 0, 5. It's up here. And I'm going to put 0, 5. So I'm going to substitute into y is less than 3x. So I have 5 is less than 3 times 0. And I get 5 is less than 0. So 5 is not less than 0. 5 is less than 0 is not true. So that means that 0, 5 is not a solution. And then I can circle the conclusion. Points in the unshaded region are not solutions to the inequality. Now here it tells you the shaded region represents the solution to a linear inequality, which is known as the feasible region. In your own words, describe the feasible region. So they already told us it was the shaded region. See what you can conclude here regarding solutions and not solutions. So you should have made a statement about the fact that all the points that are solutions are in the feasible region. Okay, so I think we're ready to turn the page. So now we have a new inequality. We have y is less than or equal to negative 2x plus 10. So the first thing you want to do is pause the video and type that into Desmos. Okay, and I can't really see the y-intercept, so I'm going to zoom out a little bit. Other way. Okay, so now I can see a y-intercept at 10 and an x-intercept at 5. I can see a solid line, and I can see that it's shaded below. So that's what I'm going to do here. Y-intercept at 10, x-intercept at 5, a solid line, and it was shaded below the line. Okay, so to describe the graph, I could say that it had a solid line and that the shading was below the line. Alright, and the feasible region should still be the possible solutions, and it's going to also be the shaded part. So the shaded part is the feasible region, and that shows the possible solutions. Or I won't even say possible, it just shows the points that are solutions. Okay, so this graph is different from the previous one because we have a solid line. So we are going to test the point that's on the line, and you can choose any point that's on the line. Alright, so I'm going to choose the point that's at 1, 8. Right there. 1, 8. Alright, I'm going to substitute it in. So my y is going to be 8 is less than or equal to negative 2 times 1 plus 10. I get 8 is less than or equal to negative 2 plus 10. And finally, 8 is less than or equal to 8, which is true because one of the choices is equal to. So 8 is equal to 8. So this is true. And so we can say, yes, 1/8 is a solution. So I can make the conclusion now that points on a solid line are solutions to the inequality. Alright, so now what we're going to do is we're going to graph both of these at the same time and see how this changes our shaded area. So let's go ahead and put that into Desmos. You can pause the video while you do it. Okay, so now you can see a triangle that's shaded here. It's shaded by both the blue side and also by the green side. So this triangle is now our feasible region because it's shaded by both functions. So this triangle has some points that we're going to try to get onto our graph. It has this point at 2, 6. It has a point at 0, 0, and it has a point at 5, 0. So let's try to get those points onto our graph. So we had 2, 6, 0, 0, and 5, 0. And then this line here was solid, and then this line here was dashed. And then we're going to shade below because this part here was shaded by both graphs. And it continues down like this. So what is different about the shading regions of this graph? What is the feasible region and how can you confirm your answer? So we could check points. So the shaded region is different because we have two inequalities. The feasible region is where the inequalities overlap. And we can confirm our answer by checking some points. So we're going to check some points now. It says, based on the graph alone, determine if the following points are solutions for the set of inequalities. So that means we have to find our answer by looking at the graph. So we're going to look for the point 2, negative 5. So the point 2, negative 5 is going to be way down here, but it should be shaded if I continued my shading here. 2, negative 5 should be in the shaded area, so I'm going to say yes, because it is in the shaded area. Alright, now we're going to look at the point 2, 6. So 2, 6 is up here. Now that one's a tricky one because it looks like it's on the corner of the triangle, so we should include it. And it's definitely included in the solid line here. But because it's not included on the dashed line here, we actually cannot say that this one is a solution. So we're going to say no, and it's because it's on the dashed line. Alright. And now we're going to look for 12.5. So here's 6. 12.5 is going to actually be way off the page over here. So 12.5 does not look like it's going to be in the shaded area. It's way out of it, so I'll say no. And it's not in the shaded area. But of course, we can also figure this out algebraically. So that's what we're going to do on the next page. Okay. So because there's a little bit of work involved here, you may want to split up into experts A, B, and C again. And you can split up the work, but then make sure you get back together to share your results. So we're going to check and see if the point 2, -5 satisfies both inequalities. Our prediction, based on the graph, was yes, 2, -5 does, but we're going to check them just to be sure. So remember, this is your x and your y. So I'm going to have -5 is less than 3 times 2. I get -5 is less than 6, so that checks out. Now over here, for y, I put -5 is less than or equal to -2 times 2 plus 10. So I get -5 is less than or equal to -4 plus 10, and -5 is less than or equal to 6, which also checks out. So since it works in both inequalities, we can say yes, it's a solution. Alright, let's go back to the 0.26. So what did we say about the 0.26? We said no because it's on the dashed line. So let's check it out algebraically. So here's your x and here's your y. I'm checking in y is less than 3x. So I'm going to put 6 is less than 3 times 2. And I get 6 is less than 6. So 6 is not less than 6. It doesn't even matter if this one works or not. We can already say no, because if it doesn't work in one of them, it doesn't work at all. Okay, the last point was 12.5. If we want to look back, we can see we predicted no for 12.5. No, because it's not in the shaded area. Alright, so let's check it out. That's my x and my y. So y is less than 3x. 5 is less than 3 times 12. So 5 is less than 36. That one works. Okay, let's check 12.5 into the next one. So y is 5 is less than or equal to -2 times 12 plus 10. I get 5 is less than or equal to -24 plus 10, and 5 is less than or equal to -14. That one doesn't work. So if it doesn't work for either one of them, then it's a no. 4 says, if your prediction was incorrect, what are the reasons? So if you did make an incorrect prediction, you would want to write your reason here. Alright, so the reason why we did all of this practice with inequalities is because it's useful for a technique called linear programming. And linear programming can be used to solve some real-world problems. So let's look at those. In number 4, we did that. In activity 2, we're doing linear programming, and these are our goals, so you can pause the video and take a minute and read over them. But here's our problem. After a hurricane, a humanitarian group is sending food and clothing to victims. Each food container is estimated to feed 12 people. So you can see that here. Here's my food container, and it will feed 12 people. And each clothing container is estimated to help 5 people. Organizers want to determine the number of containers of food and clothing to maximize the number of victims helped. So later on we're going to get into the information about weight and volume, but right here it says X represents the containers of food, Y represents the containers of clothing, write an equation that expresses the number of victims to be helped in terms of x and y. So if we simply add the containers of food plus the containers of clothing, we can find out how many people we can help, and that's going to equal n, the people that are helped. This equation is called the objective function. So we use the objective function at the end of the procedure. You want to determine the maximum number of people that can be helped, so we're looking for the largest result we can get from this, but we don't graph the objective function. We're going to graph our inequalities on the next slide, but we never graph the objective function. So let's move on. Okay, let's see. The aircraft that ship the containers have weight and volume restrictions. Such limitations are called constraints. So constraints is a vocabulary word. Each constraint must be translated into an inequality in order to form a system of linear inequalities. The graph of these inequalities then forms the feasible region. So here are our restrictions. The weight cannot exceed 19,000 pounds. So you have to think to yourself, if it cannot exceed 19,000 pounds, that means it could be 19,000 or less. So that would be a less than or equal to. The total volume must be no more than 8,000 cubic feet. So no more than means it could be 8,000 or less. So it's another way to say less than or equal to. All right. Each food container weighs 50 pounds. Each clothing container weighs 20 pounds. That information was on the containers when we looked at them. 50 pounds, 20 pounds. Write the aircraft's weight constraint as a linear inequality. So we know the food containers are 50 pounds, and we have X food containers. So 50 times X will give us the weight of the food containers. We need to add in the weight of the clothing containers, and the clothing containers are 20 pounds, so that will be 20y. Alright, now the weight cannot exceed 19,000 pounds, so we're going to say less than or equal to 19,000 pounds. So this is our weight constraint. We also have volume constraint. So each food container has a volume of 20 cubic feet, so that would be 20x. And each clothing container has a volume of 10 cubic feet, so that's 10y. And then remember, we said also that volume is going to be less than or equal to, and that's 8,000. So it says the inequalities x is greater than or equal to 0 and y is greater than or equal to 0 are often constraints. Explain what these two inequalities mean in the context of the problem. So you want to go back and see what x and y represent. And if you know what it is, you can pause the video and write it. You can see here x represents the number of food containers. So if I say that that number has to be greater than or equal to 0, I'm saying you can have no negative food containers. And you also can have no negative clothing containers. So those constraints make sense. Alright, so we're going to graph that and we're going to find the vertices. Vertices are like corner points. So we are going to graph these two and these two as well. So we have 4 to graph. So you can pause and do that on your own. I'm going to do that right now too. Zoom out so we can see it. Okay, and then we were going to add in, I think, we were going to add in x is greater than or equal to 0. And y is greater than or equal to 0. Okay. So this is interesting because we have actually points in a number of places. Let's see. We have less than or equal to 1900, so that's here. I'm actually going to take these two off because I think they're confusing things for the moment. Okay, so just looking at these two, I've got a purple shaded area and a gray shaded area, so you can see a little purple and a little gray, but it looks like the area that is shaded by both of them is actually perhaps is in here. I'm going to change my color so I can see a little better. Okay, there we go. Alright, so in this we would also have greater than or equal to 0 for both the x and the y. So we would have this shape with 4 sides to it. So we have 0, 0, we have this point 0, 800, 300, 200, and then over here, it's not that point. 4, nope, that's not it either. I might need to zoom in more. 380, 0. Alright, so we're going to take a minute to write those points. And the point 0, 0 is a corner point, but I might leave that one off because I didn't leave enough space in my chart here for another one. So I'll leave off 0, 0 because I know that that cannot give me the highest number of victims help. 0 plus 0 is not going to help me out there. So I am going to do the 380, 0. That'll be one of my feasible points. Alright, and then I had one here, which was 300, 200. Supposed to actually put them in here, wasn't I? Alright, so we said that was 380, 0, 300, 200. And then let's look at the last one. It's up here. 0, 800. Okay. So x plus y is going to equal n, so I have 380 plus 0. I have 300 plus 200, and I have 0 plus 800. Alright, and remember the other one was going to be 0, 0, which was 0 plus 0. So this one helped 380 victims, 500 victims, and this one here helped 800 victims. So the maximum number of victims that could be helped would be 800. And that would be 0 for x and 800 for y. So let's go back and see which was x and y. We can look at a picture. I think that's the easiest thing. So food is x and clothing is y. So we can help the most people if we had 0 food and 800 clothing. Okay, and that's it.